do this.
Okay, so this is non-honors 2. All right, so what I want, guys, couple of things. Here's what we're going to do. Shh. Okay. Let me make sure I did this in class. When I talk, guys, when I said, I want to make sure I'm covering you guys in class. When I talk about, for constant acceleration, the change in distance is equal to 1/2 a times delta t squared, right? Right? There's one thing that I want to make sure, I can't remember if I covered this in class. Did I do this yesterday? That the total change in distance that I travel is the change in distance due to my constant acceleration plus the initial velocity that I might have times delta t. Did I do this?
Yeah.
I did do this part. Where this is from my initial velocity. So the idea is that this. Here's the idea. For this portion, okay, it's velocity versus time, right? Where I'm starting from 0 and accelerating, okay? The area under the curve, delta d, is this, okay? Right? We all know this, right? The area under the curve is area under a v times t curve or vt curve is delta distance, right? Change in distance, and that change in distance for acceleration is this value right here, 1/2 a times delta t squared. That assumes that idea is if I'm at a stoplight and I hit the gas when it turns green and I accelerate from 0 velocity. The problem is if I'm driving next to a semi-truck at 60 miles an hour, and I want to pass the truck, and we're both going 60, I've got to hit the accelerator, don't I? So that graph ultimately looks like this. Like this. Okay? Where I'm traveling at a certain velocity for a little bit of time, right? And obviously this portion of the graph represents what kind of velocity? Constant. Nice. Everyone see that? And so the area under the curve, this delta distance, is just my v times my delta t, right? Right, v naught. The problem is, once I accelerate, the area under the curve is all of this.
Trapezoid.
It's a trapezoid. But you can look at it this way. It's this acceleration point, that delta d, plus the delta distance if I kept at that same speed. Do you follow what I'm saying? So it's like, I use the term alternate reality choice, but some people don't like that term. The distance that I would travel, this bottom 2 rectangles represents the distance I would travel if I never decided to pass the truck. Okay? But if I'm going to pass the truck and accelerate, I'm going to get even more distance because I'm accelerating, right? As time moves on. So it's really that distance I'm going to pass. The distance I'm going to go anyway, but with the addition of the time that I'm going to accelerate for, that distance I'm going to accelerate on. Does that make sense? I'm getting some blank stares. Jude, give me your thought process. Where's your question? Come on, you can say because I know there's confusion about that.
I don't have any. Wait, is that you're saying when you do the arrow, you're saying that to the left and to the right?
Yeah, what I'm saying is that the idea that this is, I'm talking about this graph on the left, this constant acceleration, 1/2 at squared, is the same representation here. This distance is 1/2 at squared, right? So this right here is 1/2 a times delta t squared. And this distance here is v naught times delta t. So this whole trapezoid is this plus this. You follow me? And so when we talk about, so if I'm going to be traveling some distance, the amount of distance that I travel depends on my initial velocity and how in that time it goes, plus the amount of accelerating for that same time. Does that make sense? So the difference being is this. If I drop the ball, do I have an initial velocity? When I drop the ball? No, when I drop the ball, the initial velocity is 0, so that's why this term goes away, and I'm left with just the 1/2 at squared, dropping the ball for distance. However, if I take the ball and throw it down, what happens? Yeah, I have an initial velocity, don't I? When I throw it down, I get initial velocity. So I'm going to get down there faster, aren't I? Right? Yes, ma'am.
What is after V after, yeah.
V naught, V initial,
Oh.
my initial velocity before I accelerate. Sorry, I write V. I write the initial velocity V naught or V initial. I apologize. I do that. I'm just letting you know. It's the same thing. No. It's like V naught. V naught. The initial velocity V naught. You'll see it both ways, and I write it both ways. I apologize. Does that make sense? So I want you to know that there's this equation here, and this is a really powerful equation. You should really have that equation there, because and that equation can be rewritten another way. If I look at that equation, really, what's delta D break out to? Thank you. Beautiful. D final minus D initial equals 1/2 A times delta T squared plus my initial velocity times my delta T. So you can actually say my final position is equal to my initial position plus my initial velocity times delta T plus 1/2 A times delta T squared. And this is the standard format for this equation, but I like this format better I'm not saying you should do anything, but I'm just saying I personally like this one better because it clearly explains in chunked form what everything's doing, right? The total distance you travel is do the distance for acceleration constant and your initial and your constant velocity. So those two pieces. Does that make sense? Okay. All right. I'm gonna. Can I move on to a different?
Wait, can I write?
Yes, please. Because we're gonna use this here in a second. Rachel, you awake?
Yeah.
Okay. Tell me what I can tell you guys all. Yeah, and when you're writing this down, make sure you're writing this and understanding it, and not just writing blindly. Make sure if you've got questions on this, ask me. Does anyone have any questions on this formula at all and how it relates? And okay, all right. We'll do a problem. Okay, here's the thing. All right, let's assume that I've got a ball. We're going to do the exact same problem. We've got a ball, and it's going to have an initial velocity of Vy of equaling -5 meters per second. Okay? So I'm throwing the ball down. All right? Let's say let's say there's the pink elephant. I cannot draw an elephant to save my life. I gotta go draw another elephant. It's a really tall elephant. Huh? Yeah. Okay, here's my elephant. All right. How long, if my elephant, if my ball is, oops, why is it? Why is it sometimes the shift works, sometimes it doesn't? If the ball is 36 meters above the elephant, okay? How long does the elephant have to get out of the way before it gets hit?
So how long does it take for the ball to hit the ground?
Yeah, essentially, right?
Well, you have to account for the elephant's height.
How's that? Good. Fine. All right, you get how so you guys work this problem out. I want you guys to work this on your own. You've got the equation that you got. You got to think about again. Follow the steps. Lay out your facts. Okay? Lay everything out that you know about this problem. Okay?
Oh, is it the initial velocity?
So think about what planetary facts. Think about what kind of motion this ball is having. Okay. Work together on this. Work together, guys.
What's the height of the elephant?
It's just to the top of it. I've already the 36 meters. Just use a distance of 36 meters. So if it's gonna hit the in 36 meters, it's gonna hit the elephant.
Okay, so between the top of the elephant and where the ball is.
It's 36 meters.
Oh, so you have this. What are you asking for, Jim?
I want to know how long the elephant has to get out of the way.
Okay.
What is my delta t for safety? Okay, hold on. I want to put these tables back in like group order as well.
I like this one.
I kind of like this. Drew, do you have an answer? Okay. Are you trying to do it right there?
I'm just looking at my
It's when you get delta equals it, and delta t plus 1 equals it. And then you get two answers.
Right, you get two answers.
There's two different.
Yes, ma'am.
Wait.
You guys not done the quadratic formula before?
Well, I do that. Okay, why there's two answers?
Because it's a parabola. The answer, the quadratic formula is a parabola. You have to figure out which answer is correct. Okay.
Oh, what are you writing? X equals negative b plus or minus the square root of b squared minus 4 eventually, this is like the first thing. When you're running the first equation. I use this. Oh, what? Oh, sure. Plus the initial one.
Okay, so.
We don't know time.
Okay, so you use this equation. The 1/2 one, right?
Yeah.
Okay, so then it's 36.
Yeah.
But then what
We
you
know this. Yeah, well,
There's it's 75
times delta t
but you have to do delta t. That was
squared plus initial velocity.
Someone remind me the quadratic. It's negative b plus or minus. All right, it's negative b plus or minus the square root.
B squared minus
4ac or 2ac? Is 4ac? Okay, minus 4 over 2a. Okay. Sorry, I don't remember this. Okay, there you go.
Wait, you have to get 25. See, I told you to do that. I didn't do it. You looked at me all weird. I told you to do that. Oh.
Oh.
That's a weird quadratic.
That ain't quadratic, man.
Huh?
Quadratic.
What do you mean it's not
You're
quadratic?
getting quadratic.
You're not getting a quadratic?
Yeah, it is a quadratic.
It's a quadratic. X squared.
36 over 25 equals delta t.
Okay, hold on. 5 plus or minus the square root of 25 times
But don't you multiply 5
Yeah, you have to multiply.
5 which is 25?
4 times 5 times 36, 720 plus 25, 740, 45. Ah, shoot. All right. Because I've already had initial velocity. Constant velocity, yeah. Okay? All right. So what I have done up here for you guys is I've worked through this. Has everyone worked through this problem and done this? Who's still working on it? Okay. Okay, my final answer is 2.22 seconds. Well, you're going to get a negative time or a positive time. Can you have negative time? No. I got 2.22. Do you have this? 5 plus or minus the square root of 745 over negative 10? I'm sorry? Your neck, well, it should, well, because somewhere along the way you did, there's a negative issue.
Wait, Mr. Ed, what's the quadratic plus the right?
This one?
The quadratic.
Here?
Yeah.
It's 25, which is 5 squared, but negative 5 squared, 25. Minus 4 times negative 5, so that times 36, right? So that's going to be 25 plus whatever that multiplier is, right? Solving for time is not trivial in this scenario.
Okay. It's negative 36 big than your
Yes, because my final is 0 and my initial is, right? Because, now, but that's because I determined that my acceleration is negative 10, and my velocity is negative 5, and down is negative. That's why I determined that. Okay? Everyone there. All right, what I want, so I'm gonna offer another problem. Here we go. Okay. 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 Here's what we're gonna do. Are you ready? I don't think so. I don't think so. All right. All right. I'm gonna have a ball, and it's gonna have an initial velocity of 0. Okay. It's gonna roll off my ledge. My ledge. Actually, I'm gonna do it this way. Okay. Okay, here's what we got. Mm-hmm. Shh.
Put Wile E. Coyote in the
Okay. Now, Siva, what are you doing? Okay. Here's what I want you to do. The ball is going to roll off. Okay? All right. And I'm going to do this from. Okay? Ball's going to roll off. At the time the ball rolls off, this little cart is here.
It's just gonna flip the card because the cart's not centered.
The cart is here. The cart is moving at a velocity that I want you to determine. What is the velocity the car has to go to for the ball to reach the inside, just to be caught by the cart? Okay? So what is the velocity the cart has to be? If it's 10 meters away from the drop zone, huh?
25 meters.
It's 25 meters to the top of the. Listen, let's. I understand you want to get the specifics, but let's not get to that detail just yet. Let's nail the simple stuff first, okay? So it's 25 meters to reach the cart. All you gotta do is get this cart to here in 10 meters. The cart has to be here in 10 meters, and the time it takes to travel 10 meters. At the same time as the ball has to reach 25 meters down.
What's the initial velocity of the ball?
Well, what do you think it is? If it just falls off, then
You know what I'm saying?
okay. Well, no. No, Gabe. Gabe, you gotta think about it. The ball is here, and I'm just pushing it off. So it's like I'm dropping it. If I'm dropping it, what's the initial velocity? 0. All right, so let's go. This is an important thing. What you're gonna have to figure out here. You have horizontal motion and you have vertical motion, and there's a connector here. You got to figure out what the connector is. Think about it. I want you guys to think about this.
So what's the question? How long?
No, the question is, what is the velocity of the car? What does the velocity of the car have to be in order for the car to catch the ball? Should you freaking out? Okay. Just a smidge. Okay. I want you to freak out a smidge, but I want you to get over the freak out. Yeah, right? Yeah. I want you to think about it. I want you to think before you start putting numbers to paper. I want you to think about the logic. What has to happen? Think about it. Think about what has to happen in order for the ball to be caught by the cart. Talk through it in general terms. What has to happen before you start writing equations down?
Do you want it to does there be any overlapping in between time where we're like shut the part over and already has reached its destination? Just so like another second on the ball gets it. So
I
you want the time where I slid that cart right under
this cart is traveling at a velocity, and it is 10 meters away from the drop zone the moment the ball starts to fall. So when this ball falls, this cart is 10 meters away, traveling at a velocity that you need to determine.
What if I push it 20 meters per second and it reaches the spot, but there's still plenty of time for the ball?
It's going to keep going. It's going to go. It's going to go through. The car will not stop.
Yes.
Then we'll deal with that. Okay, Gabe, for you, Gabe. For Gabe, this length of the cart is 1 meter. I want max and min velocity. Yes. Go, come on.
What kind of engine does your car have?
Huh?
What kind of engine does your car have?
It doesn't matter.
Are we talking like EcoBoost V6 or like
We're talking
like steel V8?
Come on, guys.
So then you do 5
Guys, you need to, before you start doing that, you need to make sure you have a conversation about what has to happen at a higher level. Rachel, can you work this on so you're not working by yourself? Both of you, Rachel. Can you guys work together in some fashion?
We're talking about
I feel like we're not capitalizing on the conversation.
yeah, so then you put 2 Yeah, that's good. So the challenge with the part is going to be the fact that there's no No, but I'm saying that like what we're doing is I'm cross-checked.
Charlie, you have an answer?
Yeah.
You good?
Yeah.
All right. Can you, for those of you who have answers, can you make sure you have someone else who has a correct answer, the same answer with you? Walk around the room, make sure you, does anyone else have an answer? Can you guys check? And then go around the room and help each other out. When you're done with, guys, when you're done with your problem and you've got it right, go talk to other people and help them. Teach them. Help them. All right. Okay. So guys, let's talk about the key thing about this key strategy for this problem. And let me take one step back. First off, when you looked at this problem initially, did you think, holy, bleh, right? Yeah? But when you sat down, you thought about it, you were like, oh, wait a minute. You lay out your facts. I know you're going to see that. I know oftentimes in a test you see this and you go, holy, Mr. A. But if you take your time and think about it, you can get through the step. What is a very high level strategy? What are you trying to do? Hold on. What are you trying to do? High level strategy.
Figure out how long it takes to involve it in the ground.
Because why?
Because that amount of time needs to be covered. That amount of time is the frame in which you have to cover things.
Okay. The issue is this. I've been very clear about this. Listen up, guys. It's very important. Very important. The amount of time it takes for the ball to fall should be the same amount of time the cart takes to get to the ball in order to catch it. The connector between the horizontal motion and the vertical motion is time. That's the most important thing I want you to get here. All right. Thank you, guys. Enjoy.
This